Alright, so let's do it the opposite way now. I'm just going to do number 12. You're going to try to do these for homework. So for number 12, it says tell whether the ordered pair is a solution of the system. Alright, so here they show you a system of inequalities here for number 12. And we want to see is negative 5, 25, one of them. Well, our x is 25. Right? And where is 25? Well, let's see how this is going up. This is 15. 1, 2, 3. So that means it's going by 5, 10, 15, 20, 25. So we see on the x-axis, 25 is included, right? But what about in the y? Well, negative 5, we can't see that, right? But we can assume that this is negative 5 because this is going by 5s as well. So that's negative 5. And if we go over, we can see that that point is there, right? And because these are arrows, we know that these are keep on going. So that point is actually there, and so this one is a solution to the system. All right, so you do the same thing for number 13 here and number 14 to see if those two are solutions. Are those points one of the solutions to those linear inequality systems of linear inequalities? All right, so for this one, I'm going to do 21, 22, and 23. And for homework, you do the rest, 24 and 25, 26. For this one, what we want to do is match the systems and graphs to see which graph belongs to which one. And so here we have number 21, and we want to see, there's only two lines. So because there are only two lines, we know it's not that one. Right, that one has three lines as they bounded the x-axis, because the x-axis is blue. Right, and that's how one way you can knock them out. We know it's not E because this y-axis is bounded because it's blue, not black. Right, this one has three lines as well, so we know it's not that one. This one has three lines as well, so we know it's not that one. So it has to be either B or C, as these are the only ones with two lines being utilized. So now that we've narrowed our way down, let's go ahead and decide if it's B or C. This first one says y less than or equal to 4. So we're just looking for y equals to 4, positive 4. And you can see already it's not B because this is down at the negatives. And so this one here is 1, 2, 3, 4. And it's a solid line as you see there. So the first one checks out. And then the second one's at negative 2 on the x-axis, which checks out. And it's a greater than sign, a dashed line. And then it satisfies the shaded region. Right, and that's how I do mine. So you see, there's only one shaded region there. There's not many different colors. When I work it out, it's bam, that's my answer. But anyhow, that's our answer for 21. 21 is C. All right, let's look at 22. Once again, only two inequalities, and we've already narrowed down that was only B and C could be two. So that made it easy. B. All right, so our B and C are out. All right, so now let's look at number 23. Number 23 has three of them, and the A, D, E, and F are all three inequalities, as you see from 25 to 26 as well. All right, so the first one says y greater than x, so we're looking for a y equal to x line, and I showed that in the graphing chapter. So if you remember what y equals x looks like, remember that's 1 equals to 1, 2 equals to 2. Whatever your y value is, your x value is equal to. And it creates a nice, easy to be identified, easily identifiable line. And hopefully you can see that. That's our line, y equals to x. And so we've already kind of narrowed it down because none of the, I take it back, this is a y equals to x too. So we have to decide between E and F. So those are the two that have y equals to x. And they both have y greater than x. So we see that they both are dashed lines. So we move on to number 24. The second one. They differ in that they have very similar ones. They look like they're trying to trick you up there. So the next one, x is greater than negative 3. Notice it's an x, whereas this one's a y. Remember, the x lines are vertical. So which one of E or F has a vertical line through negative 3? All right, so which one has x as negative 3? We can see that here, 1, 2, 3. So we already know which one is the correct one. It's F, as that one is clear. And I guess I've already assisted you in finding number 24. But let's just go ahead and just see how the rest work. The other one is y 0, and we can see that here as well. That's the line y equals to 0. And then we could check the shading. We already know that it is f, but I just want to really make sure you understand. And so the last thing that you want to do is check the shading. Let's say you get one that's really, really close and you can't tell the difference. So the shading, y is greater than x. Well, that means everything above the x, right? Then the other one, x greater than -3, that means to the right of that line. And then y greater than or equal to 0. Oh, sorry, I did the other way around. Y greater than up is above that line. And so you can see the common region would have been right here. And so if you needed to tell by the shading only, that's another way to do that. All right, so remember for homework, do number 24 through 26. All right, our last question here is going to be an example, a real life situation. And it looks like I am drawing this graph. I didn't put a graph there. All right, so it says flight attendants. To be a flight attendant, you must be at least 18 years old and at most 55 years old. And you must be between 60 and 74 inches tall, inclusive. Let X represent a person's age in years, and let Y represent a person's height in inches. Write and graph a system of linear inequalities showing the possible ages and heights for the flight attendants. All right, so they already tell us what variables we're using. Our x will represent our years, and time is always the x-axis. And so where do we see years? So the youngest the person can be is 18, so that's inclusive. So that means greater than or equal to that. So x is greater than or equal to 18, but the most they could be is 55. And you're including these ages, so we use the less than or equal to sign. Then it gives us the y. They tell you what to choose for y. Y represents the person's height in inches. And so, how tall must they be? They have to be in between 60 and 70. Okay, and they let you know that you're going to use the greater than or less than or equal to signs by using that term inclusive. So we have 60. They are greater than or equal to 60 inches, but less than or equal to 74 inches. Right? So if you were the person deciding if a person is a candidate, you can actually program this into a computer, and as the person puts their age and their height, the system could reject them. And that's the beauty of knowing how to write inequalities or write equations. You can program software to make life easier. All right, so now we just need to graph that. And because we're going to have 18 to 55 and 60 to 74, we're going to have to edit this a bit. And we could use that break. So let me create my y-axis and a little break there. That's where 0 would be. And then do another one here. And that's going to be our x-axis. X, y, and that's our time in years. And this is our height in inches. Okay, so for our years, they're going from 18 to 55. This is going to be 20, 30, 40, 50, 60, and 70. So 55 would be about here. All right, and then for our inches is 60 to 74. Okay, so let's go ahead and draw this. A person could be 18 years. We know they can be in the negative realm, so let's say that's about 18. All right, so let's say that person is 18 years old. Look like that, a little bit straighter, of course. That's going to be our x equals 18 line. And then at 55, that's about here I wrote. And there we go. I mean, you don't really need the arrows per se because you're stopping at 55. But it is technically an arrow there because a person could be 55 and 50 inches, 55 and 60 inches. So you want that to go as high as possible. And so we have our lines doing that. And then on our y-axis, the inches that we want, person has to be at least 5 foot tall. and they could be 20 years old, 18, so about here. Try to keep that straight. And then, because somebody could be 60 inches, but that's not what we're including. And then somebody being 74 inches, you could be 74 inches and 80 something years old, and you could be 74 inches and be a little bit younger there. Right, but we just want to get what's in common. And hopefully you could just see it already without having to do all that shading. It has to be greater than 18. Greater than 18 is everything in that direction, right? And then less than 55, right? If greater than 18 is to the left and 55, sorry, to the right and 50, less than 55 is to the left, you can see that it has to be in between the two purple lines. And if the person has to be older than 60 but less than 75, you see that they have to be in between the red lines. And so to fit all of the above, then that means it's bounded by this rectangle. Right? And that's the example of doing it without many different shading. And so you can see anything that I choose here could work. If I choose any point, so if I choose someone who's 40 years old and 65 inches, that will satisfy, right? So anything inside here will work. And so your program, if you created software, will spit out the correct output based off of the input that goes in, like any function would. And so that's your answer, as you have answered what they want. Write and graph. You wrote it and you graphed it.